You guys ready to have some more fun with these trigonomic ratios? Yes, of course we are, Miss Smith, right? Okay, guys, today what we're going to do is we're going to switch gears a little. We're still going to be using the trigonomic functions, but this time we're going to use what's called the inverse of the trigonomic functions of sine, cosine, and tangent in order to solve some problems. Now, let's talk about what that looks like, and then I'm going to show you on your calculator how do we find these inverse functions, right? Okay, so let's look at our notes first. Okay, so first of all, remember, we've got our trig ratio, sine, cosine, and tangent. Okay, now, you use those when you know one acute angle and you're trying to find a side length. Okay, but now I'm going to show you guys when we switch gears, okay, we're going to solve a right triangle, which means that we're going to find all of the side lengths and all of the angle measures in a right triangle. Okay, but what about the inverse trig functions? Well, the inverse trig functions come into play with this. You use the inverse trig functions to find the missing angles. Okay, you use it to find a missing angle measurement when you know two side lengths. You will only use the inverse trig functions to find an angle measure. Okay, now I want you guys to notice this. Do you guys see that there's this little -1? That right there, that is saying the inverse tangent or the inverse sine, inverse cosine. Okay, when it has cosine to the -1, that means inverse cosine. Okay, so that's some symbols that you're going to see here in just a second. Okay, all right, so there are some tables that are on the rest of your notes. Okay, and you can use those tables to help you figure out what do I use when? Because if you guys notice, like there's a lot of different things with trig, isn't there? Okay, so if you are looking for an angle, notice this says here the measure of angle A. Look, we use the inverse tangent, but the ratio is still the same. It's still opposite over adjacent. Okay, so the only thing that changes is that now we don't know the angle measurement, we're going to find it. On this table, on the second page of your notes, this kind of helps you figure out what to use and when. Okay, so you have a column that says, what do I know? That means what do you have? Like what measurements do you have? Or what are you looking for? And then what are you going to use to find it? Okay, so you can refer back to this as we're working out some of the problems. All right, let's go look and see. Guys, I think we're going to start with number 4 today, but before we do any of that, we have to know how do we do these inverse trig functions in our calculators. So, guys, take a look at this video that I made that shows you how to use your calculator with the inverse trig function. All right, guys, now for the calculator, okay, to do the inverse trig functions, okay, we're still gonna CYC, right? Check your calculator, hit mode, make sure that you are in degree mode, okay? And then now to get to the inverse trig functions, guys, if you look on your sine, cosine, and tangent keys on your calculator, up above it in blue, it says sine to the -1 or cosine to the -1 or tangent to the -1. Okay, so what you want to do to get to the inverse is you hit second and then sine, and that will take you to the inverse cosine. And this is where you can put in the ratio and then you hit enter, and it's going to give you a number. Well, guys, that is the measurement of the angle. Okay, this angle would be 48.6 degrees. Okay, same thing if I hit second, okay, cosine, that gives me the inverse cosine. I put in the ratio, let's say the ratio is 4/18. I hit enter. Oh, that angle is 77.2 degrees. Okay, so when you hit the second and the trig function, it gives you the inverse of that trig function. So let's put in another one. Let's do 9 divided by 4 for the tangent, and let's see what it tells us. Oh, that's going to be 66 degrees. So these are the angle measures that we found using the inverse trig function. So you hit second and then the trig functions, and it will give you the inverse function. All right, I'll see you guys back in the original video. Now you guys know where the inverse trig functions are and how to get to them. But remember, CYC, right? Check your calculators, because you need to make sure that you are in degrees before we calculate any of this so we get the correct answers. Okay, so number 4 is what we're going to do first. On question number 4, it says to solve the right triangle. That means we are going to find every side length and every angle measurement. Okay, it says we're going to round to the nearest tenth. So the very first one, guys, it says to find the length of BD. I'm going to highlight that. BD is over here. Okay, so what do I have to start with? Hey, guys, do you notice that we have 2 side lengths, don't we? If we have 2 side lengths and we want the third side length, well, what do we use? Let's go look at our chart. Okay, if we have 2 side lengths and we want another side length, then we use the Pythagorean theorem. Okay, so let's use the Pythagorean theorem. Okay, before I even start this, okay, which value always are we going to plug in for C in the Pythagorean theorem? Yeah, guys, we're always going to use the longest side, which is the hypotenuse. Okay, that's going to be our C, isn't it? Okay, all right, so let's take a look at this. Let's do this. Let's see if I can get this. All right, so we're going to do a squared plus b squared equals c squared. And we just said we're going to plug in the hypotenuse for c squared. So that is 21 squared. Okay, and then we know one of the side lengths, so that would be 15 squared. And then we don't know the length of BD, so that's just going to be my a squared. Okay, now, guys, use those mad algebra skills and rounding to the nearest tenth. Guys, what do you guys get for the length of BD? Good job. All right, so if you happen to miss that one, that's okay. Look at my work, see what you might have done wrong and made the mistake, and guys, just fix it. Learn from it, right? Okay, so BD is 14.7. There's no units on this, so it's just 14.7. Okay, so we found BD. All right, good deal. Now it's asking us to find the measurement of angle B. Okay, angle B. This is what we're looking for. We don't know that angle measurement. All we know in this triangle is that we have a 90-degree angle. Okay, so if we want an angle measurement and we have 2 side lengths, well, we got to figure out which trig function to use. Okay, so let's label our picture. All right, so remember, we're looking for angle B, so that's our reference angle. So the 15 is our opposite because it's across from the reference angle. The 21 is the hypotenuse. And what's left over next to the angle is our ADJ. Okay, guys, just like we practiced the last 2 assignments, we're going to start with what we have and figure out what we want. Well, hey guys, right here, we have the hypotenuse and the opposite. So, which trig function are we going to use if we have the hypotenuse and the opposite? Yeah, we're going to use sine, but because we're looking for an angle, we're going to use the inverse sine. Okay, so the measurement of angle B equals the inverse sine, so it would be sine to the -1 of the ratio. So the ratio is still going to be opposite over hypotenuse. So opposite is 15, hypotenuse is 21. And guys, we're going to put this straight into our calculators just like this. You're going to hit the second key and then sine, and then 15 divided by 21. Okay, so after you do that, hey guys, what did you get for the measurement of angle B? And remember, round to 1 decimal place. Alrighty, so if your calculator was in degrees, then it gave you that angle B was 45.58, which rounds to 45.6 degrees. If you did not get that, CYC, check your calculators. Okay? All right, now, guys, we're going to back up, and this time we're going to be looking for angle C. All right, well, there's a couple different ways that we can solve this. Okay, right here is C. So I can either say, you know what, angle B right here is 45.6. So if I know two angle measures and I want the third one, hey, I can use the triangle sum theorem. Or, guys, now we're going to relabel our triangle. Okay, so what I'm going to do, instead of relabeling it, I'm going to redraw it out here for us. Okay, so I've got this triangle. Okay, I know that, dun dun, this is 21, this is 15. Here is my reference angle. This is C. This is what I'm looking for out here. Okay, so now, okay, here's my right angle. I know that's kind of hard to see. Now I've redrawn that triangle. I can still figure out which trig functions to use. I can label my triangle. So let me zoom in here. Okay, this is for C. Now, this becomes my opposite side because it's across from the reference angle of C. The hypotenuse still stays the hypotenuse. That doesn't change, does it, guys? Okay, and this one now becomes the adjacent. Okay, so now, guys, if we look at this, we still have the hypotenuse, but this time we have the adjacent. So now, which trig function would we use if we have hypotenuse and adjacent? Yeah, this time cosine is adjacent and hypotenuse. But remember, we're looking for an angle measurement, so we're going to use the inverse cosine, aren't we? Okay, so angle C equals the inverse cosine of, and we have to put in our ratio. Okay, hey guys, which one is the correct way to put in this ratio? Yeah, guys, it's adjacent over hypotenuse. Okay, 15 over 21. All right, come on, guys, give it to me. Put it in your calculators. What do you get for the measurement of angle C? There we go. 44.4 degrees rounded to the 10th place. Okay, now I want you guys to notice something about what I did. Guys, in every single one of these, I used the given information to help me find all of the other measurements because I rounded this value right here. So I want to make sure I always go back to the given information. That is going to give you the most accurate answer. Okay. All right. So, hey, guys, let's practice another one together. Okay. Let's go do number 6 together. We'll do one more. All right. Down here at number 6. Now, here's what I'm going to ask you guys to answer for me. It says that we are looking for the length of AC to start out with. Okay, so which method should we use right now to try to solve for the length of AC? Which method? Yeah, hey guys, if you looked back at your notes, it says I have 2 side lengths. I want the third side length, so I'm going to use the Pythagorean theorem. Okay, hey guys, make it happen. I want you guys to set up the Pythagorean theorem. Okay, and remember, okay, right here, I'm going to give you guys a hint. That is always your C, isn't it? The hypotenuse is always your C. Okay, guys, go and tell me, round it to the nearest 10th, what do you get for the length of AC? Did you guys bust it out? Okay, look and see. Did you get that 8.7 is the length of AC? All right, if not, again, guys, take a look at my work. Okay, see what happened there. All right, now we're going to look and see. It's asking us next to find the measurement of angle A. Okay, to find the measurement of angle A. That's this angle right up there. Okay, so what method should we use? Well, we know 2 side lengths. We want an angle. We're going to have to use trigonometry. The question is, which trig function are we going to use, right? Are we going to use cosine? Are we going to use sine? Are we going to use tangent? So, guys, I want you to label your triangle with opposite, adjacent, and hypotenuse. And then I want you to tell me which trig function should we use to solve for angle A. Okay, let's see if you were on the right track. Okay, first of all, look to make sure you labeled your triangle correctly with our reference angle at angle A. And then we have the opposite and adjacent. So you should have said the tangent, or more specifically, the inverse tangent function to solve for angle A. So we go down here. So angle A equals the inverse tangent of, okay, and we do opposite over adjacent. So 8 over 3.5. All right, superstars, put that in your calculator and tell me, what do you get for the measurement of angle A? All right, you should have gotten that the measurement of angle A is 66.4 degrees. Okay, all right, now we need to go do angle C. So, guys, take 2 seconds, redraw the triangle, relabel it real quickly so that you can accurately figure out which trig function to use. All right, because we're going to be looking for angle C. So if you're looking for an angle, you're going to be using the inverse trig function. All right, so here's 3.5, here is 8. This time it says that we are looking for angle C. All right, guys, go label this triangle, and I want you to tell me which of the trig functions or the inverse trig functions would you use to find angle C? Hey, what do you know? Look, we still have opposite and adjacent. They're just in different places, aren't they? So, yes, we're still going to use the inverse trig function. So angle C is going to equal, angle C is going to equal the inverse tan of opposite over adjacent. So 3.5 over 8. All right, you guys know what I want next, right? What'd you guys get for the measurement of angle C? Nice going. Okay, so you should have gotten 23.6 degrees. All right, again, I'm going to zoom out here so you guys can see. Solving a right triangle, that's what it means. We found all of the side lengths and all of the angle measures in this, okay? All right, now, ladies and gents, you are going to be doing some other problems that are going to be word problems, and you're going to be doing those during class, so make sure that you draw a picture, okay, and label it. And guys, when you do a word problem, okay, especially here in geometry, think real world, okay, think real life, okay, the ground is going to be like this. Well, in real life, okay, a ski slope. Hey guys, a ski slope is slanted, isn't it? Okay, so think real life when you're setting up these problems. Okay, guys, I'll see you guys next time. Until then, adios.